Welcome to another STEM Tech Ed Tinkercad tutorial. The purpose of this tutorial is to provide additional practice for students currently learning how to create 3D computer models. My students can find the project documents posted on Classroom. Fellow teachers, feel free to contact me directly if you are interested in using those project documents with your own students. In this tutorial, we will be exploring the Workplane tool to more easily place shapes exactly where we want them and introduce some 3D printing concepts. This is also the first time we will be collaborating through Tinkercad with fellow students. I will show you in class how to set up that collaboration. All right, so let's get started. It's always a good idea to just go ahead and give your new design a name before doing anything else. As fun and silly as those automatically generated Tinkercad names can be, it's best to stay organized, especially as we start to add more files to our library. For my tutorial here, I decided to use Steve, the original Minecraft skin, along with Alex. I'll be designing Steve in a very straightforward position, but feel free to model your skin or mob in whatever challenging orientation you'd like to based on your comfort level with Tinkercad. As you can see here, I'm just kind of eyeballing the dimensions. So with the feet done, we'll go ahead and use the Workplane tool for the first time. Placing workplanes is a nice time saver when trying to align multiple shapes on a common plane. It is far easier and faster than trying to line up shapes by manually moving them into place. So we'll go ahead and adjust the height for the legs. It looks like we need a slight adjustment along the y-axis, so I'll just select the top box and move it slightly forward. You may or may not have to do the same. One important thing to remember is the direction of motion for the arrow keys can be affected by your current camera view. That color looks good for the pants. Now time to add another workplane for Steve's torso. You may be wondering at this point how to return to the original workplane. To do so, simply click the workplane button and then click back on the bottom blue plane. As you can see here, workplanes can be placed on any of the three-dimensional planes. So here we are placing a new workplane on the YZ plane in order to add Steve's left shoulder. Those of you who are new to working in 3 dimensions when designing, if you look going across your screen from left to right or right to left, you would have your x-axis. That gives you length or width of an object. The y-axis would be running perpendicular or 90 degrees to the x line, the x-axis, and the y-axis would be your depth measurement. And then the one that students might be less familiar with would be the z-axis. And the z-axis is what gives you height in your model. So that z-axis on that blue bottom work plane there would be providing your height dimension. Since Steve does in fact have two shoulders, we can use a little copy-paste action here to save us time of resizing a new box. So copy first, and then we'll place a new work plane for his right shoulder. And once it's pasted on that plane, just place it where you want. So just as work planes can be placed on top of shapes, they can also be placed underneath. Since both of these arms are being placed on the same plane at the same Z height, we can copy paste and just move the new arm along the x-axis to put it in position. You may notice that I am purposefully keeping the back of Steve flat. This is to make 3D printing easier later, which I will go into more detail about at the end of this tutorial. Depending on your design, this may or may not make sense for you to do as well, but the general idea of creating models that will print more successfully can be applied to anything you design. To make things easier here, I will select both Steve's head and his torso and use the Align tool to both center his head on his body and keep the back of this model flat and aligned. Here's a helpful tip. As you'll see, I just zoomed right to Steve's head. This is called focused zooming in Tinkercad, and to do it, you click on the shape or shapes and hit the F key. To cancel focus zooming, you can hit the home button that is below the view cube. For this part, I am going to change the snap grid sensitivity down to 0.1 millimeters. This will allow for more fine-tuned dimensioning and movement. So here is just a little trick to achieve symmetry for the eyes. I use the side of his head as my starting point and then count the number of times I move to the right before duplicating and doing the same with the other eye to get the even spacing that I want. We'll need a new work plane placed on the eyes to create Steve's pupils. I'll use the Align tool here to place the pupil exactly where I want before adjusting the size and changing the color. And just as I did previously, I'll use the edge of his eyes to count the distance that I move the pupils to get matching eyes. We'll follow a similar process here to create his goatee. We'll follow a similar process here to create his goatee. Now we can use the hole feature to cut out a space for the mouth. Remember, a hole shape needs to be grouped with another shape or shapes before it can actually cut out the shape that you are trying to achieve. To make things easier, we can just copy an eye and paste it to use for his mouth. I prefer to do this than to drag a new box that needs to be resized. So I realize that this is not a realistic mouth color, but Steve's mouth is not too noticeable in images, hence why I went with this color. Creating his hairline here will be very similar to creating the goatee. I really suggest getting comfortable with the Align tool, as it does make things much easier and allows you to work faster. At this point, I think it's a good idea to again utilize copy paste to place the hair on the other side of Steve's head. Once you have it where you want it, you can use the mirror tool to correct its orientation before positioning with the align tool. I'm placing hair on the back of his head for now, but I will delete it later to make a point about easier 3D printing. Whoop, sorry about that, Steve. All that's left now is to place hair on his head. Steve is now finished. For my students completing this Minecraft character challenge, you will need to export an image of your Minecraft character, skin or mob, and to do that, we'll go to the Send menu. It is important to note that the angle of the image that exports will be based on the current view in Tinkercad. So set your view first, then export your image. Let's talk a little about 3D printing. The general approach I take to 3D printing is to set up my prints in such a way where I am increasing the chance of success with the first attempt at printing while also keeping in mind the time and material required. Looking at this model, I know I will want to print it with its back flat on the printing surface. There's two main reasons for this. One, printing that way will allow me to avoid having to print supports, which act as scaffolding below an unsupported surface such as under Steve's arms or the overhang of his chin. Supports don't require much filament material, but they do add time onto the overall build time, increase the risk of a failed print, and can sometimes lead to a messier looking print as the supports need to be removed from the model. For those of you 3D printing at home, I do recommend that you use your printer's software to adjust the layer distance between the top layer of support and the actual model itself. You want a distance that provides support but does not adhere too well to the model itself. Experiment and find the value that works best for your printer and filament material. The other reason for printing this model flat on its back is to provide a more stable footprint, providing adequate adhesion to your build plate. This is especially important if you do not have a heated build plate, as prints are more likely to break free of the build plate before printing is complete. If you are new to 3D printing, take the time to learn about rafts as well. Rafts provide more stable adhesion to the build plate, but be careful with the distance from the top of the raft to the object so it is not too hard to remove after the print is complete, similar to supports. So in order to be able to print Steve on his back, I'm going to remove the hair on the back of his head and make a slight adjustment. And there we go. Steve is ready to be exported for 3D printing. Click Export in the top right and select the appropriate file type. For my printers, that would be an STL file. My students will upload this STL file to their Google Drive and submit it for printing through the Google form linked in Classroom. I hope you found this tutorial helpful. Like and subscribe for future content, and good luck creating your very own Minecraft skin or mob using Tinkercad.